Class 32, absolute value sum minimization. All right, so in this one, we're given a sorted array of integers. It's called A, and we want to find an integer x from A such that the value of this thing is the smallest possible. And we'll talk about this thing in just a second. And if we can find several possible answers, we'll put the smallest one. The thing is, okay, first of all, they mentioned that A is it's a non-empty array of integers, so it's got at least one thing in there. They're going to be whole numbers. Maybe they're positive, maybe they're negative. In fact, they could be as low as -1,000,000 and as high as +1,000,000. So they're going to cover quite a range here. And notice that like there aren't that many of them. Like we can only have up to 200 elements in the array, but the elements within can be huge. Okay, so one other thing, it says that they're sorted in ascending order. Now I believe, yeah, there is the possibility for repetition here. So really, I guess if we wanted to get technical about this, instead of ascending order, we should take non-descending order. They're not going down, but they're not necessarily going up. Okay, so let's talk about what this is then. This actually kind of is related to the title here. It says absolute value sum minimization. The minimization refers to the fact that we're trying to find the smallest possible one of these. The sum refers to the fact that we're adding all of these things up. The absolute values is what this abs thing is all about. So again, absolute value, if you're unfamiliar, it basically just means how far a number is from zero, how many units away it is from zero. So basically, if the number is -5, the absolute value is 5. If the number is 7, the absolute value is 7. So the absolute value could be the number itself. Well, basically it's just the positive version of the number. Okay, so absolute value of basically the difference between each element and x. And we see that for every element of the array, starting with A at 0, A at 1, going all the way up to the final element, which is A at A.length -1. Okay, cool. So that's basically what we're trying to do. We're trying to minimize the total distance between whatever our number is and all the elements in the array. So I guess, if we want a visual, we'll switch over to our AWW whiteboard here. This app has gotten a lot better. They, I guess, sort of redesigned it recently, and we've got a whole bunch of new features. We can do lines now, which is great. So my stuff is going to get a little less sloppy, I think. Maybe not, but anyway, the point is, we also have all these amazing custom colors that we can make now, so we're not limited to these guys over here. We can put in whatever colors we want. So I loaded up a few of them already. I guess we'll start with this color. Okay, so basically the idea is I just want to get a couple of numbers on the number line over here. Let's say we've got like, here's -5, then maybe like -1 over here. What else? 3, and I guess 7. Okay, so we've got some numbers there. I guess we could put a few more, but that's probably enough for now. And here, I guess I'll use this color. And basically the idea is that for any number we're picking here, for like our x, let's say we chose an x value that's like here, -3, I guess that would be. So what we want to tell is basically what's the total distance from this number to all the other ones over here. And we are looking at the absolute distance. So maybe I'll just stick with this color for now. Okay, so basically absolute distance, what we're talking about is like how many units away are these ones, and then also how many units away are these, whoa, okay. I know there's a line tool, but I feel I should be able to do better than that by hand. Okay, there we go, and this distance. Okay, so that's basically the idea. We're looking for the total of all these. So we would have like 2 from this one, 3 from this one, I think 6, and then 10 Yeah. And so basically the idea is we would add all those up. So 2 plus 3 plus 6 plus 10, I think it's 21. So that's the total distance here. And then, regardless of what our number is, we want to find the x value, we want to find the number, so one of these things, that's going to minimize that total distance. So it's, I guess it's ultimately like the closest possible to all the numbers is kind of what we're looking for. Now, there is something about this problem that makes it a lot less challenging than it possibly could have been. So specifically, it's this part right here. They're saying find an integer x. Actually, I guess specifically it's actually this part, the fact that it has to be from A. They're saying pick one of these elements from this array A. And then, well, not pick one, but find the one from that array that's going to minimize this distance. The thing about it that to me makes the problem less interesting when they impose this constraint here is the fact that now we're only looking at a possible 200 elements, like a maximum of 200 elements, probably a lot less. Like if we look at only 3 elements here, only 4 elements here. Whereas if it didn't say that it was from A, that it could be like any number, like, well, kind of like what we have over here, like this wouldn't be valid because this isn't one of the elements of A. So basically the idea is that that simplifies things a lot. There are much fewer possibilities to consider here, whereas, compare that to something like this, where the minimum value is -1,000,000, the maximum value is +1,000,000. It's like 2 million numbers to go through as opposed to 200. So it would really make the problem a lot tougher if we didn't have the constraint that it's specifically from A. So I think what we'll do is we'll take a look at the problem first as it is here, as it's written, and then afterwards we'll look at how we could handle it if it was just any element, like if we did not have that constraint right there. Okay, so to get started, let's write a function that gets the total distance from our current element to all the other elements. So we'll say function get total distances, yeah, get total distances with an input of, let's say, num. Or actually, should we call it x? Maybe we should call it x just because, that's what we're calling it here. And we basically want something like this. It's a sum of absolute values. So there are a few ways we could do this. We could say something like let total be assigned the value of 0, and ultimately we're going to return that total. And what is that total? Well, basically we'll just say for let num of A, we're going to say total plus equals the absolute value of the difference. So basically num minus x. Okay. And is that it? Gonna return that total? I think that might be it. Let's see. Let's try this. We'll say return get total distances of, we'll just say A is 0. So we'll take the first element, or the 0th element, depending on how you look at it. Okay, great. So it's saying 7. 7 is the total distance if 2 is our number. So let's verify that. The distance between 2 and 4, the absolute distance anyway, is 2. And then between 2 and 7, it's 5. 2 plus 5, it's 7. Okay, so I think that's working correctly. Let's just try the next element. Okay, great. So basically, if we're talking about 4, then difference between 4 and 2 is 2, like we said. But between 4 and 7, it's 3. 2 plus 3, it's 5. Well, that's better. So maybe that's going to be a good candidate for our choice here. But if we really want to know like what's going to be the best, we'll just run through all of these. We'll just say let min distance be assigned the value of, and we'll just make it something really big right now. We can make it infinity. We can make it something else. It's up to you. And then we'll say best element. Let me camel case that. Yeah, let best element be assigned the value of, and we could say like null or undefined or something like that. We could even just do this if we wanted to, but I guess I don't feel great about making it not have a value because ultimately this is the thing that we're going to be returning at the end. So I'm just going to make it A at 0 to begin with. And yeah, like I was just saying, we are going to return best element at the end there. So we're going to do something really similar to the loop above. We're just going to say for let num of A, let distance be assigned the value of get total distances for num. And then if that distance is less than our minimum distance, well, that means, number one, we have a new minimum distance. It's going to be this distance. And also we have a new best element, and it's going to be whatever number we're currently looking at here. And that's the thing we're going to be returning at the end. So let's give that a run. We'll see if that's working. And yeah, it seems to be working. Okay, so let's try submitting that and see if it passes all the hidden tests. It does. Okay, so we didn't have to worry about it timing out or anything like that. And again, it's because these constraints are a lot more forgiving than these constraints over here. So we're going to flip this around in just a sec. But before we do, I'm thinking, like, in case you're a big fan of like these built-in array functions, this like functional programming style, let's change this a bit. So basically, instead of having a loop and going through the total like that, we'll just say return, and we're going to use a map and a reduce here. So we'll say a.map. So for every element in A, which I guess we'll call num, like we did down below, we're going to say this is going to get mapped to math.abs num minus x. So the difference between this number, this entry here, and x. Okay, and then we're going to do a reduce on that just to sum these up. So normally I'd do a and b for the two elements, but I guess I'll call them p and q. In this case, since a is already defined, we'll just do p plus q. Okay, so basically the map is saying, all right, every element in the array A, so maybe it's this one here, 2, 4, and 7, take each of those elements and subtract from that whatever x is. And then, if it's negative, turn it positive. So basically find the difference. Yeah, the difference. I was about to say distance, but yeah, difference works just as well. Find the absolute distance, absolute difference between our element x and every single one of these things. And basically convert these to their distance from, or absolute distance from x, whatever x happens to be, and it's the input of the function. Okay, and then after we've done that, just add all those things up. So that's where the reduce comes in. Now, in JavaScript, we don't have like a built-in just for summing up all the elements in an array. And, I guess in some ways it's kind of a shame that we don't. It would be nice. If you really want it, we could monkey patch one in. We could say like array.prototype.sum is assigned a value of function return this dot reduce pq gets mapped to p plus q, like that. And then, if we have that, then we could just change this to like dot sum, which I guess would be a bit more semantic. But anyway, let's just make sure that this is working. So we'll run that, hopefully no errors. Yeah, so that works just as well. So, point is, if you want to do something like this, you can. I guess I'm just going to take that out for now, and I'll just put that in here and get the indenting right. Main reason is because I'm only going to use this for this strategy over here. I'm not going to use this for the next one, so should I? I don't know. It's something we can do. We probably shouldn't. The main thing is that they say you don't want to put a monkey patch like this on an existing element, an existing object, sorry. And so array is definitely an existing object, like a built-in is what I mean. You should probably only do like these kinds of things for objects that you've created yourself. At least that's what they say. So I don't know, maybe for that reason we should just sort of put this on at the end here. Just the reduce makes things a little simpler, not quite as semantic, but hey, if we're worried about that, we could just put a little comment in there, right? So we could say something like, I don't know, find all the absolute distances, and that's what the map does, then add them up, and that's what the reduce does. Okay, cool. So maybe that's a little more clear to the reader. Still runs, I think. Does it still run? It still runs. Okay, cool. So, all right, we're doing pretty good with this. It's working. It passed all the hidden tests. We've got this kind of cool function in here that doesn't require any loops or anything like that. It's kind of neat. But like I was saying, I think the problem gets a little more interesting when we ignore the constraint that it has to be an element from A, that X has to be an element from A. So let's remix this a little bit. we'll just wrap that up and we'll grab this, just copy it in here. Okay, so basically some of this stuff is going to stay the same. Some of it is going to get a little bit different. So first thing I want to do is this. Actually constant. I have a constant value called min. There we go. So min is just going to be the lowest element in the array. We already know that the array is organized in non-descending order, and so we know that the first element is going to, or the 0th element is going to be the minimum, and the final element is going to be the maximum. Okay, and then instead of this, let num of a, we're going to have to say something like let num be assigned the value of min, while num is less than or equal to max, num plus plus, and then yeah, same thing, I guess, right? The number is basically just going from the minimum to the maximum. I mean, the reason I'm starting at minimum and ending at maximum is because we can probably tell, you know, like if we were to put the number over here or something like way beyond all these, it's just going to have a greater distance to all these. And like the further we go outside, you know, the further we go to the right of all these, the further we go to the left of all these, the greater that distance is going to become. Anyway, we'll look at that in more detail in just a sec, but returning to this for now, basically the idea is that we don't need to start before minimum or go any further than maximum. We know we don't necessarily, like I said, our number isn't necessarily going to fall within it's not necessarily going to be one of these elements, but it'll be somewhere between these elements. I think we can say that with some confidence. Okay, so we've changed sort of the structure of our loop. We're not just saying, okay, is it this element? Is it this element? Is it this element? Like, we're not just looking individually at 2, 4, and 7. We're starting at 2 and we're going all the way to 7. So we're going to say, is it 2? Is it 3? Is it 4? Is it 5? Is it 6? Is it 7? And that probably doesn't seem all that extreme or anything like that. But when we get into something like, oh, okay, I'm actually kind of surprised by that. Test 7, I was not expecting that one to work, I have to say, because if we look at this, it's going from -1 million all the way up to +1 million. So, okay, kind of surprising there. It still got the right value. I thought it was going to time out. Okay, well, good to know. Let's see. Yeah, okay, so is it going to pass all the hiddens as well? I guess it must if it's not going to time out on one that had -1 million and +1 million. Oh, actually it did. Okay, so, I mean, I was expecting it to time out at some point. Maybe it's just because there's more than one of those tests, so, you know, maybe it's like the test 7 was like close to timing out, and then another one of these was like, whoa, that's just too much. Okay, so, all right, this is not ideal. It's not totally working. So, let's investigate this. That's what I'm interested in. So, okay, we've got our distance here, and we're basically saying, yeah, if this distance is, if it's better than the minimum distance, then we'll do all that stuff. But I want to do something else here. I actually want to measure, like, how is the distance changing over time? That's kind of what I'm interested in. So, first of all, here, let's do a console log, console.log, and we'll get the number and the distance for this one. Let's see how that's going to work. It might not be able to output all that for test 7. Yeah. Okay, so we've got the number on the left here, 2, 3, 4, 5, 6, 7, and then we've got the total distance here. And we find that the minimum here, yeah, it is 5, and that makes sense that it would be at 4, which is the number that we're returning ultimately. Okay, so, and that's why we are getting the right values when it doesn't exceed the time limit. But that's not the only thing I'm interested in. So let's do something like this. We'll say let last distance be assigned the value of, we'll just say min -1 for now, like that. Okay, great. And then we'll say let delta be assigned the value of distance minus last distance. And then after all this, once this is all done, we'll say last distance is distance. Okay. So delta, let's put that in now as our third argument, or yeah, our third thing that we're console logging. And here we go. So, okay. Wait, did I do something wrong here with this? Class distance. Oh, yeah, it's not just min minus 1. It's get total distances at min minus 1. My mistake. Sorry about that. Okay, so let's run that again, and basically we'll be able to see the deltas. Delta meaning like, the change in something. So as we were to go from 1 to 2, our distance gets lower. It goes down by 3. And then as we go from 2 to 3, it gets lower again, so it's going down by 1, and we can see that, right? 7 to 6, it's gone down by 1. 6 to 5, it's gone down by 1. 5 to 6, it's gone up by 1. 6 to 7, up by 1. 7 to 8, up by 1. Okay, so I guess this kind of makes sense that like 4 would be our answer, because notice the deltas are all negative, 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 and then after 4, positive, positive, positive. In other words, we're saying, this is kind of like a derivative here, right? We're saying that these numbers are decreasing up to this point, and then increasing after that. We want to get it right at the point where it stops decreasing and starts increasing, because that means we're at the minimum, right? If we're decreasing, 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 and then we go increasing, increasing, increasing after that, then our minimum was basically the point where we stopped decreasing. Okay, so it's useful to have those deltas in there. Now, let's take a look at where those deltas are actually changing. It looks like, after the 2, it changed. After the 4, it changed. And it looks like those are the only times here where it changed. If we look at this one over here, after the 1, it changed. Not after the 2, after the 3, it changed. Maybe after the 4, it would change as well. We're not sure, but we're maybe noticing a pattern here. Not a good example. Maybe not the best example either. That's a little crowded. Not enough elements. Let's see. After the 0, it changes. After the 7, it changes. Maybe after the 9, it would. I think it's just the numbers that are inside the array here. So we could do something like this. Like if a dot includes num, then we'll do another console.log, and it'll say something like num is in the array, delta will change. That's going to be our little prophecy here, and we'll see if it comes true. We're console logging quite a bit now. We're writing a short novel with some of these. So, okay, cool. Great. 2 is in the array, delta will change. And it did. It went from -3 to -1. And then it doesn't change after that. 4 is in the array, delta will change. -1 to 1. Okay, cool. 7 is in the array, delta will change. Well, I guess we don't get to see that, but we would if we were console logging like the next thing. Okay, and that seems like it's consistent. Like basically in between all of these messages. Oh boy. Okay, so there's not really so much of an in-between for this one. I think pretty much all of the elements are in the array there. What was that good one we were looking at a second ago? Was it this? Yeah. So basically in between these messages where we say delta will change, it doesn't change. Like all of these are the same. They're all -1. It's not changing. These are all +1. It's not changing. It's only when we encounter an element that's in the array that the delta changes. Let's find out why that is. So basically, if we're looking at this over here, here's our -3. Now, let's say we want to look at, and I guess I'll switch colors ever so slightly. So we'll say that this one is going to be -2 now. And the idea is that this distance would increase. So we get a bit more of a distance on that, but we would also decrease. Whoa, that eraser's too big, man. Can we make it smaller? That's the smallest eraser size? Wait. Oh, okay. It's not that big. Cool. So basically, we're getting rid of all of these parts here. Oh, hey, that's really nice of you to say. I really appreciate that. But I don't need to save it right now. That's fine. And so we'll keep that going. There we go. So basically, what we're getting is we're increasing the total distance by 1, right? Because we're moving 1 unit away from the -5. But we're also moving 1 unit towards the -1, the 3, and the 7. So basically, that's why it's going up by 1, but also it's going down by 3. So basically, it should be diminishing by 2 here is the idea. And then if we increase it again, I guess that would bring us to the -1. Then again, this, whoops, still on eraser, sorry about that, pen. So this now would increase by 1, but the other distances again would decrease. So again, our delta here is going to be -2. It's going down by 2 again because it's going up by 1, down by 3. Okay, so now this brings us to a more interesting point. We'll switch colors again and go back to the pen tool. So now let's say we get to 0. And what we find with 0 is now we're increasing this distance. Well, this distance had gone to 0 because we had actually arrived at the element. So now we're actually increasing that distance as well. And we're decreasing that distance and decreasing that distance. So basically now the delta, it's balanced out. It's 0. Because this, the -1, when we were over here, when we were to the left of it, every time we incremented our num, we were moving towards the -1. We were decreasing the distance by 1, decreasing the distance by 1. But now that we've traversed the -1, now we're moving away from it as num increases. So now it's going to increase by 1, increase by 1. So basically, we're losing one of the elements that we were moving towards, and we're gaining one of the elements that we're moving away from. And really, as it turns out, that's the main thing that matters here. How many elements are there that you're moving towards, and how many elements are you moving away from? That's really the thing that matters. So what we notice is basically we're decreasing, 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 and then kind of staying the same, stagnating here. And then increasing, 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 because at this point, between the 3 and the 7, there's a majority of numbers that we would be moving away from, like all 3 of these, the -5, the -1, and the 3, we're moving away from those, we're moving toward just the 7. So basically, what we'll find, and I mean, okay, so distance here, like the total distance, for -1, for 0, for 1, 2, and 3, they're all going to be the same. Like all of this, it's not going to make a difference. The delta is 0. So -1 would work, 3 would work, anything in between would work. But the problem did say if there are multiple possible answers, output the smallest one. So we'll choose the -1 here. We'll say, yep, that's going to be our winner. That's the one. Okay, so really what it comes down to is this. How many elements are there to the left of our number, and how many elements are there to the right of our number? How many array elements are there is what I mean. Basically, what we want is for our total distance to decrease, and then just as soon as it stops decreasing, pick that element. We're done. So basically, my claim is it's always going to be the element that has, how do I put this? Basically, the number of elements up to including that one is not less than the number of elements after that one. That's what I'm trying to say. So basically, there are 2 over here. There are also 2 over here. And we could have like much more of these, like or fewer. Like we're looking at 0, 7, 9. While the 7 is a number, the 7 is a number that has only one thing to the left and only one thing to the right. So it's a good pick. It should be right at the middle there. If we look at the -4 and the -1 here, well, we'll choose the -4 because up to and including that element, we don't have fewer than the one over here. So it's kind of like we're picking not so much an average, like it's not the mean element we're looking for, it's more like the median, if you remember your measures of central tendency. So the median is kind of like the number that's in the middle of the array. So in this one, it's, well, you could say it's the 1 or the 3, but we're going to choose the 1 because that's the first one that sort of applies here. If we're looking at this one, it should be the 4. So really, if we really want to get into it, if we really want to make this as simple as possible, well, could we just take the median element? Could we just say, like, return a at a dot length divided by 2, or something like that? Will that work? And my prediction is no, it won't work, because sometimes, like a dot length, if it's 3, then a dot length divided by 2 is going to be 1.5. Well, we don't have an index of 1.5 for any of our elements, so of course we're going to get a null. So what do we want instead of the 1.5? Well, really, we wanted the 1. So maybe we'll do a math.floor on this thing. Math.floor of a dot length divided by 2. Okay, but now that's not working for some of them. So 5 out of 7, that's pretty not bad. It works for this one, but it's not working for this one. Why is it? It's giving us the 3. So let's think about that. What's the length here? It would be 4. 4 divided by 2 would be 2, so we don't have to math.floor that at all. We have the 2 already. The thing is, 2 isn't what we're looking for. 2 is too big. So, we could subtract 1 from this. But now we're going to have a new problem because now this one is too low. So basically the problem here is we had a length 3, divide that by 2, we get 1.5. We're flooring that 1.5, so it's a 1, subtract 1, now it's a 0, and we've gone too far. So instead of floor, we're going to use ceiling. Don't round down, round up. Math.ceil. And look at that. As you could hear, I could barely contain my excitement for that one. So is it going to pass all the hidden tests? Could it be this simple? Yeah, it could be. Okay, so interesting thing about this is even without our restriction here to just elements from A, even without that, we still get the same result. Like, as it turns out, it always has to be an element from A because it's only at those elements of A that we're actually changing the delta here, that we're actually stopping to decrease or maybe decreasing less and starting to increase after that, or maybe plateauing for a while, but this is the first one we find. So I think that's really neat. I think this is a really interesting problem, and I think it'd be kind of cool to sort of give someone like this problem as it is, without, just like this, give them this problem and then say, oh, okay, now here's a harder variant of that. What if it wasn't necessarily from A? What if, you could choose any value of X whatsoever? How would that change things? And the sort of the interesting conclusion there, the twist ending on that would be, it doesn't change anything. Okay, so are we done? Did we submit? I think we submitted. Yeah, cool. So, however you want to do this thing, if you want to actually do the loop here, up to you, or, well, okay, I guess the lesson to be learned here is when you really engage with it, when you really grasp and understand the problem and the sort of nuances of it, you start to notice patterns, you start to notice things that can make the problem just so much easier. I mean, it's like pattern recognition and stuff like that, right? And that can really set you free. It can improve your code in, as we saw here, pretty much every possible way. It's more efficient, the time complexity is better, the space complexity is better, we don't have any additional variables or anything like that. And the human readability, we could argue, is better because there's so much less to actually read. You could also argue that the human readability is maybe worse because it might be harder to the reader to understand why this is. But think about it this way. Look, we're replacing, what, a dozen lines here? Spend that dozen lines writing a nice comment explaining how this stuff is working. So, the element with minimum distance from all the others will always be, maybe I didn't have to do it. I'll let it just wrap around naturally. Okay, will always be the median of the array. There we go. That kind of explains it, I think, right? We can get into more detail, like try to draw a little ASCII art of this or something like that, but I think this is probably good enough. I think we could even, just like the app was offering, we could like save our board and then maybe make a link to it and put that in here or something like that. I don't know, it's up to you. If you're worried about this not being clear to the reader, we've got options, is all I'm trying to say. Okay, cool. So I think we're done with that one. Let's just submit that, make sure this comment gets saved, and that's it. Yeah, let's get out of here.